Hi ladies and gentlemen, once again, I'm going to make a video and you can watch it. This time it's about the quiz you took yesterday, which I didn't grade because I quickly looked over and there were a lot of people who seem to have no idea what's going on, which leads me to believe you didn't watch some of my other videos. So we're going to go over a couple of these questions and you can kind of grade your stuff on your own. And then I'm going to talk a little bit more about some colligative property type problems, okay? So, ladies and gentlemen, here we go. All right, the first problem we're given is to calculate the molarity when you are given a percent, okay, and a density. Excuse me. So the first thing you have to do when you see the percent is assume that you have 32.7 grams of silver acetate, AgCH3COO, okay, in 100 grams of solution. Now, which that already tells you you have, I'm going to take 100 minus 32.7, that's going to come up with 67.3 grams of solvent. So that's before we've done anything. That's just straight from what we have here, okay? So that's the start. Now, in order to determine molarity, okay, molarity equals moles over liters. Well, moles is simple enough to find. You have 32.7. So what I'm going to do is I'm going to take 32.7 grams AgCH3COO. I know this is really icky writing, but that's just what my stylist will do. And I look for its molar mass on the periodic table, which I have next to me, but I've done this before, so I'm going to do 166.92 grams in 1 mole. Now when that happens, I end up getting, I got point, and I'm writing it down here so I have room, 0.1959 mole. Well, that's great. Now I need to get liters, okay? Well, liters is a little bit different. It's liters of solution. The only way to deal with that is by using density. Okay, so density equals mass of the solution over, okay, the volume of the solution, which, ladies and gentlemen, you know the mass of the solution. It's 100 grams. So I'm going to do this density is 0.784 equals 100 grams over x. This is how I get liters, okay? So I go through and I do the math and I end up getting x equals 127.55 ml. Unfortunately, for molarity, we needed to bring that over to liters. So I'm going to do molarity over here, okay? Moles over liters. So I'm going to do 0.1959 divided by, and I'm just moving this 1, 2, 3. 0.12755, and I end up with 1.54 molar, big M. Now, what about molality? Molality is moles per kilogram. Well, we already know moles, so it's going to be 0.1959. And guess what? We already know kilograms. It's solvent, and we got that up here. I'm circling it right now. It's so exciting. Okay? I just have to change that out of grams and into kilograms. So literally it's 67.3 and I just move it 1, 2, 3. So it becomes 0.0673 kilograms. And when I do that math, I end up with 1.5, oops, it's not 1.54. That was this one. Whoops. It's 2.91 little m. Okay? That is how you do these problems. I know it's kind of a pain, but you gotta practice with them. All right, let's try the next one. Number 2 was just a dissociation equation. So you had to take K3PO4. It's ionic, so it dissociates into its ions when it's put into water. That's what the AQ means. So there's only 2 ions. There's always a cation, and in this case it's K+, okay? And that's aqueous. Plus the anion is PO4. It's a polyatomic ion, and it says on the back of your periodic table it's AQ. So, or it says it's -3. So now the problem is this isn't balanced. I have a total charge over here of -2, and I have a charge here of 0. And I have 3 Ks over here, 3 Ks, but I only have 1 right here. So what I'm going to do is I'm going to put a 3 right there. And when I put a 3 in front of it, now my charges are 0. And I have the same amount of potassiums. So there we go. So now how do you figure out the I value? It's 3 plus, how many PO4s are there? 1. So the I value for this is 4. All right, that becomes important in the next question. All right, here we go for the next question. The next question is a colligative property problem, okay? And colligative properties are used by, we're going to do delta T equals, since this is freezing point, we're going to call it KFI, and then molality. All right, so the thing is they tell us we have 47.8 grams of potassium phosphate. That was the last slide, K3PO4. And it's dissolved into 740 grams of water. So the first thing we got to do is molality. Molality equals moles over kilograms. So I'm going to start with 47.8 grams, K3PO4. And I am literally going to get on my periodic table, look up my molar mass. I get 212.27 grams in 1 mole. Okay? And that ends up becoming 0.225 mole. And I can divide that by, check this out, it's over kilograms. They gave us grams, which is almost like giving you kilograms. You just have to move the decimal point. And I ended up with 0.300 molal. So now I just have to plug this into the equation. Okay, so KF was 1.86. The I value was 4, the molality is 0.3, and I end up with, that doesn't need to be a third equal sign, 2.232 degrees Celsius. So what does that mean though? That is the delta T, okay? That's delta T. That's just the change. So what's the new freezing point? Well, the original freezing point of water is 0. And it's called freezing point depression, so we subtract 2.232, and our new freezing point is negative 2.232. If we're going to follow sig figs, it could just be negative 2.2 degrees Celsius. Boom. That's it. So this is the actual answer. Star, star, star. Okay? So ladies and gentlemen, that is the quiz, okay? And I think that you should be able to do all of those. Now, what I'd like to do is I'd like to do some of the colligative property worksheet problems that you may have missed. You can skip this part if you haven't done them yet, or you think they're easy, or you can just check it, but that's what we're going to start with. So here we go. Here's the next slide. All right, so like I said, colligative property. Here we go. This is on worksheet 1. It's question 5. What is the change in boiling point? So all it's asking for is delta T of a 1.25 molal of sugar in water, okay? And it told you what I is, which won't always happen, and it told you the K boiling. So literally, delta T equals KIM. Thank you, steel. So we take K, it's 0.52. We take I, it's 1. We take molal, oh my gosh, they gave it to us. So most of these are fairly simple, and we would do the math. Now, before I had everything calculated, now I don't. So I'm just gonna take my 0.52 on my handy dandy calculator plus 1.25, and I got 0.65. That is the change, okay, in boiling temperature. If I were to ask what the new boiling point was, what you'd have to do is take the old boiling point, which is 100 for water, and it's boiling point elevation, so we add 0.65. The new boiling point is 100.65 degrees Celsius. All right, so that's a very basic colligative property, and they gave you the molal, which is awesome. It doesn't always work like that. Here's the next one. Now, what's the change in freezing point? So this is delta TF of a 0.78 molal solution of NaCl in water. Oh, here's the deal. It says the Kf for water is 1.86. Assume 2 for NaCl. How do you know that? Well, let's think about this. NaCl breaks down into Na plus 1 plus Cl minus 1. So that's 1 plus 1. I value is 2. So delta Tf equals Kim. Oh, Kim. All right. So now we just have to plug and chug. 1.86 times 2 times molality, 0.78. And we're going to get an answer. So this is 1.86 times 2 times 0.78. And I get 2.90 degrees Celsius. And since it's freezing point, you are going to subtract. Well, this is the actual answer the question is looking for. But the new freezing point would be when you take the old freezing point, which is 0, freezing point depression, so you're minus 2.90. So your new freezing point is negative 2.90 degrees Celsius. This is new freezing point. This is delta T. So that's another of a very similar type of problem, and I think that these shouldn't be too hard for you. All right, let's try another one. All right, a solution was prepared by dissolving 0.42 moles of hexane into 500 grams. Oh, guess what? We have to calculate our molality, and luckily they gave you moles. So all I have to do is 0.42 divided by, not 500, 0.5, because that needs to go into kilograms. So I get a molality here. It's going to be close to 1. It's going to be 0.84 molal. What is the change in freezing point versus pure CCl4 of the solution? Oh man, and they tell you Kf, and they even tell you I for hexane. And you would have known that hexane if they gave you the formula. Oh, they didn't. Hexane is covalent, but they didn't even give it to you, so you have that. So the deal is delta T, which is what they're looking for, change, equals Kim. So K in this case is 30. Okay. I in this case is 1, and molality is 0.84. So now we just have to multiply those all out, and I end up with 25.2 degrees Celsius. Boom, boom. That equals delta T freezing. That's it. You don't even have to get the actual new freezing point because we're dealing with carbon tet, and that's not the same as water. So we're not even going to deal with that. All right, so now we're going to move on, I think, to the harder. Now we're going to go to worksheet 2. Okay? Worksheet 2 asks, when 5 grams of calcium chloride dissolves with 50 grams of water, what's the boiling point? So here's the deal. It doesn't tell you what to do. It doesn't tell you KF or KB. It doesn't tell you any of that. The deal with KB for water, it's 0.52 degrees Celsius per molal. Okay? So that's for KB. Well, I know that the change in temperature equals Kim. So I now know KB right here in this case. I for CaCl2, I can figure out CaCl2, not Cu, breaks down into Ca plus 2 plus Cl minus 1, except for there needs to be 2 of them for it to cancel out. And if I count up my I's, there's 1 right here, and there are 2 right here, so my I value is 3. That's just the number of particles that are dissolved in water. And then I have molal. So this is pretty simple. We would have to do moles over kilograms. So we are given moles. We're given 5 grams CaCl2, and you gotta find the molar mass. Ugh. And I haven't done this yet, so this is going to take me some time. Calcium on the periodic table is 40.08, plus chlorine is 35.45 times 2. I end up with 110.98 grams of CaCl2 in 1 mole. I know, you're loving it. It's the most exciting video you've ever seen. Now I just do the math. 5 divided by 110.98, and I end up with 0.045. We're just going to go with that. I'm going to go 451 for the heck of it. That's molal. So now we just plug all our numbers in. We go 0.52 times I, which is 3, times 0.0451, and I'm going to multiply it on my handy dandy calculator, and I get an answer of 0.0703. That's my delta T. And here's the deal, that's delta T boiling. And it wants to know what's the boiling point of the solution. Well, what's the boiling point of pure water? Boiling point of pure water is 100 degrees Celsius. And it's called boiling point elevation, so we add 0.0703. So the new boiling point is 100.0703. And I know that really stinks for those of you who love sig figs, but this is kind of important that we write that all down. So ladies and gentlemen, that's a harder one. So we have 2 more to do. All right, so now this says find the boiling point of a solution containing 6 grams of benzene and 35 grams of naphthalene. I think this is the hardest one that's out there. First off, benzene, covalent. That means covalent. Okay, I had to spell it. I equals 1. Naphthalene. We have not dealt with naphthalene. That's not water. That's okay, because what I'm going to do is I'm going to grab my phone and I'm going to ask what the boiling point of naphthalene is. Actually, I'm not, because I don't think Suri will understand me. So I'm just going to Google it. I'm going to say boiling point naphthalene. Oh, it's right there. And man, Google is great. 218 degrees Celsius is its boiling point. So what's going to happen is when we add this benzene, this naphthalene boiling point is going to go up. Okay? Now, how much does it go up? That's what we deal with. Oh, you know what else I got to get? Ooh, I got to get the K value for naphthalene. So I'm going to write into my Google. I'm going to write KB. I'm going to actually write K boiling point, naphthalene. Oh, it's coming up. Man, I'm having trouble. I'm not getting it. Let's go to a page that says colligative properties. Colligative K constants. Yeah, let's see if we got colligative K constants. Let's see. I need a list of them. This isn't giving me a list. Oh, wait. Oh, where's naphthalene? Oh, I got a freezing point for naphthalene. I don't have a boiling point. Uh-oh. Well, I'm going to say KF for naphthalene is 6.94. And then I'm going to look at a different site to see if I can find a KB. Not there. Maybe this wonderful website will help me out. Not there. Colligative KB. I'm changing my search. Naphthalene. Oh man, this is so exciting. I know. No. Oh. Normal boiling point. Naphthalene. Normal. Does it give me a KB? Oh, it sure does. KB equals 5.80. Sweet. Cool. All that time, and it took me there. I know, what a pain. Meanwhile, while we're back in business here, what's the formula? Delta T equals KIM. So we're going to do boiling. So that would be 5.8 times I, which is 1. Oh, and I need to figure out molality. Well, how do I do that? Oh, molality. I'm going to do it right over here. Molality is moles over kilograms. So all we got to do is change our 6 grams of benzene, I'm just going to call it B, into moles. 1 mole of benzene, which I know is wrong to write B, but I'm going to do it anyway. I look it up on the periodic table. 6 times 12.01 plus 6 times 1.01. I get 78.12 grams. And I go here, 6 divided by 78.12, and I end up with 0.0768 molal. Awesome, I'm just going to put it right in there. Oh, that's not molal, that's moles. Oh, because now, I'm going to move over here, I have to do that over kilograms. 0.0768 mole over 0.035 kilograms. And now I'll get an answer, 0.035, and I end up with 2.19. Multiply this all out, and my delta T is 12.73 degrees Celsius. So this is boiling point, so it's elevation. So what we're going to do is take our original boiling point of 218, add 12.73, our new boiling point is 230.7 degrees Celsius. So here is our final answer. Was this one really hard? Yeah, because you didn't know stuff. Are you going to be asked a question like this on the test? No, because you have to look stuff up, and we don't like you using your phone during the test. So you can do it. It's just a matter of looking up and looking and finding the things you need. All right, one more. All right. My feet are aching at the end of a long day. At home, I dissolve 26.0 grams of Epsom salt in 1.5 kilograms of water. What is the freezing point of this solution? I don't really care that I'm going to freeze my feet. That's not really my goal, but let's deal with this. I've got to remember delta T equals K-I-M. It's KF, and KF is 1.86 degrees Celsius per molality. Okay, so now I know K, so I'm going to go 1.86. Do I know I? Well, let's find I. I, we would take MgSO4. You break it down, it's Mg plus 2 plus SO4 minus 2, 1, 2. So I equals 2. So there we go. And now I have to figure out molality. Okay, so molality is moles over kg. I have 26 grams of MgSO4. So I need to figure that out into moles. So 1 mole of MgSO4 has a mass. Let's see here. Mg is 24.31 plus 32.07 plus 16 times 4. Come up with 120.38 grams. Cool. 26 divided by 120.38. Man, that's 0.21598. I'll round at the end, moles. Now, how do I get molality? I have to do it per kilograms. Oh, so they told me it's 1.5. Sweet. So I just divide this by 1.5. Boom, my molality equals 0.14, let's do 399. Sweet, so I can put that in there, 0.14399. And I do a little math. Times 2 times 1.86. And I end up with a change in temperature of 0.535 degrees Celsius. But that's not what it's asking me. It's asking me what the freezing point is. So I'm going to draw an arrow that goes over here and say original freezing point of water is 0. It's depression, so it's minus 0.535. So my new freezing point is negative 0.535 degrees Celsius. Boom. This is the actual answer. I hope this helped you out. Your homework is to practice these hard problems and make sure you get them, and then work on the study guide. I would like to go over the study guide on Wednesday so you're ready for your test on Thursday. watch the other videos. They're there. And if you have any questions, email, okay? Ask in the email, or you can ask Ms. Fuhr, you can ask Ms. Desai, you can ask any of the other chemistry teachers, ask each other. I'd say there's a handful of people who did this quiz perfectly, okay? Watch out for that. So have a great day, and I will see you tomorrow.